Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream right here on Twitch. We actually use no libraries, no engines, no nberries, and no lengens. So we're completely engine library free and all combinations thereof here on Handmade Hero. And right now we are in the middle of writing our own asset processing system. Well, I shouldn't say asset processing system, asset loading system. We've done a bunch of the work over the past week, and we just have a few more things to finish up before we can actually call our asset file system a replacement for loading regular files off the disk randomly, which is what we were doing before. I'd like to get right to it. There's really not much to discuss. We all know what we're doing. If you've been here for the past couple days, you know what we are doing. Here on day 150, if you would like to follow along at home and you are one of the fellows who has pre-ordered the source code on handmadehero.org. Wait a minute. Why does that say twitter.com handmadehero? Is that that's some kind of link foo right there. There we go. handmadehero.org. If you pre-ordered the game on handmadehero.org, what you'll want to do is unzip day 149 source code. That's the source code I'm starting with right now, and that will allow you to follow along with me at home if that is the sort of thing that you are into. All right. So we already got a test file written out that has all of our assets packed into it. So really all we have to do right now is actually start using it. And in order to start using it, as you can see, if we actually run the game right now, we've essentially got no assets loaded because we commented out the sort of debug code we had written to fill our asset table at runtime. So all of the stuff that we had working with the little hero in here and the trees and the grass and all that stuff is not working because it can't get any assets. It doesn't crash, which is nice because our system is pretty swanky that way. But it would be nice if we could get some of our bitmaps back. And of course the music is not playing either because that was also one of the assets. So what we want to do now is we want to, again, take more steps toward getting everything loading off of the asset file. We did yesterday, we got the tag array going, and so I'm going to go ahead and finish up the other arrays here. And we've got two different other arrays that we have to actually handle. One is the assets, right, themselves. So let's go ahead and spin through the assets like so. Assets, asset count, asset index. And we're going to do the exact same thing here as we did in the tag array. We're going to pull out two different things. We're going to pull out the source, which is from the HHA assets array, right? And we know, again, where those are because all we have to do to get something in the file, if we want to figure out where the assets array is, all we have to do is start at the beginning of the file, which we've loaded into memory, so we know it's at this address in memory, and jump ahead however far the header tells us that particular array, where that particular array lives. It's going to give us the byte offset into it, right? So we can do that. I guess we might as well, while we're here, also do the asset type. So let's do asset type, like so, and just get all of these things sort of prepped and ready. So that's going to be asset types, right? So then when we spin through here, I guess I should leave this commented out for a second. So then when we spin through here, we're going to have the source and the dest, right? Assets. So we're going to be reading from the asset definition here, and then we're going to be doing something at the destination with the destination here, right? Let's go ahead and compile that, make sure I didn't make any mistakes there. Oops, tag index is no good. I think I might just change that to index. Let's go ahead and do it this way so I don't have to keep changing that. There we go. And then we'll also want to do the same thing when we loop through the asset type array. So we're going to go through here and go index equals 0, index less than. This time we actually want to use the header, right? We want to use the, and in fact, I don't know, to tell you the truth, we may really want to always use the header. We may want to do header tag count here, header asset count, because we may later start concatenating these things together. So maybe it's a little bit cleaner, just mentally speaking, even though we're not going to actually deal with this at all at the moment. Something, to think about. So in here, right, we've got our stuff loading now, and we just have to actually do something with it. So we've got our HHA asset type source here as well. There we go. And then the dest, in this case, is going to be a little bit different, so we're going to have to play with that. But now that we've got all that compiling, we have our loops that are spitting through the data that we actually have. So if we want to actually process these guys right here, what we're going to have to do is look and see what do we actually have for an HHA asset, right? And you can kind of see the structure here. We've got what the tags are, and those are going to translate directly, right? And in fact, what I could do here is also have the asset struct up so we could take a look at what the one that we want in memory is, right? So there's that. So if I want to copy these, right, I'm going to want to first set the first tag index, and I'm going to want to set the one past last tag index, like so, right? I want to handle those by just copying them directly from the source, because it's the same data either way, right? So I'm going to go ahead and copy both of those. But then I need to, do two different things depending on whether I've got a sound or I've got a bitmap, right? So what I want to do is take a look at the source and see what type it is. Remember, we store in here for each asset in the file, we store which type it was. So the type ID is going to tell us. I don't actually remember where that code is. Wait, that's the asset type array. That's not what I'm talking about. Oh, so we don't actually know. This is interesting. We didn't actually store this in the file. We only, because we don't actually need it when we actually go to load something. So that's kind of a little bit tricky there, right? That's interesting. So maybe I won't actually do what I just said. Maybe we don't want to actually have to switch on that because we don't really need to do that. So maybe what I want to do is just go ahead and actually take that data directly. So if I look in here, I've got my asset and I've got the bitmap info and the sound info, right? But those bitmap info and sound info were these old things that that aren't actually representative of what we're actually going to store for the stuff now. So I wonder if it's better for our asset to literally just be one of those HHA assets. Like, could we do that? Could we just have our assets actually just be the HHA assets directly? And I don't actually know if we can or can't. Another way to look at it would be if I want to take a slightly more baby step, I could do it this way, right? What would that be like if I did it this way? So let's find out what happens if I recompile that, right? So if I take a look here, when we do asset sound info, when we're retrieving the sound info, right, that would no longer retrieve the actual sound info. That would retrieve instead. Where is that? The HHA sound, right? It would return this stuff, and the HHA bitmap would be that. Now we could still, if I wanted to, actually instead of returning, I could actually build that on the fly, but I don't think I'm going to. So let's just see. I'm just going to see what happens if I actually do it this way. So if I did HHA sound, well, I guess that would actually just work, I believe. Don't really have to do anything, just change which struct it's returning, really. So that's pretty easy. And the assets, what is it? .sound, assets ID value. Is that not? Why would that not? I thought that's what exactly that's exactly what that would be. Oh, right, because it's HHA.sound. Yeah. So there we go. And then we've got the bitmap. Same thing would be happening here, right? This would actually be HHA bitmap that comes back. Let's see. File name, that's true. File name is not going to be that because we're not actually going to be calling this anymore. So we'll have to actually deal with this. This is essentially a not implemented to do. Actually do loading here. So what else we got? Asset sound info. This is again HHA sound, like so. And that's going to come out of the HHA information. Again, to do Casey. Actually do loading here. What else we got? Let's see. First tag index. So these it's just going to be that, right? It's just going to use those directly. Same thing here. Using them directly as the thing that came out of the file. What is this first tag index? Is not a member of asset. Oh, this is the copy. So this is not actually, this is just the copy. So all we have to do for the copy is just block copy the whole thing over, right? Like so. All right. So then we got asset sound info. That's actually going to be HHA sound now, and still should have most of the stuff that it would normally have. Prefetch sound can convert from U32 to sound ID. That's actually okay because that is a sound ID, right? So I can do something like this, next ID to play. Although I also could just start, I should probably just actually use sound ID and bitmap ID in the actual file. There's really no reason not to do it that way. So inside file formats, we could say that the bitmap ID, sound ID stuff, there's no reason I couldn't actually do that in Handmade file formats, right? Because they're fully specified, right? So that seems pretty safe if I wanted to do it that way. That seems like a pretty reasonable thing to do. So I could just say that's a sound ID, and off we go, right? So then these guys go away. There we go. And these just have to actually be done like this, right? Binary equals, next ID to play dot value. I guess I don't even need to use the dot values anymore on those guys. There we go. One thing I do want to know about, though, is I'm not sure. So I feel like we do have one other thing, which is the width over height thing. But, well, we'll take a look at that in a little bit. All right. So back to the story. Back to our story as it goes. So as we're loading these things, all we would be doing is putting those sources over, just copying the asset information directly into the thing that we were going to use there. Right? And what we're going to have to do temporarily in order to make all this work, although we don't want to do this in the end, we won't actually be using this. But what we do want to do, too, is have a little U8 star here, which is like HHA contents, right? We want to store that because we're going to need to pull stuff out of it in the future after the initialization phase, right? So we're going to actually need to remember that base of the file. And that base of the file is going to tell us, right, where we can grab the assets out from. So we go through here, and we're copying everything out, and I think everything's set. We just need to now deal with that asset type array. And remember, that asset type array is a little bit different than the other arrays in that it just actually stores sort of a table that tells us what type of asset we're dealing with, and then where the range actually was, right? So what we're going to have to do here is our destination, right, our asset type. So our destination is actually going to come from a lookup that it works with the source, the source's type ID, right? We're going to say, go to the asset type array and grab out the entry that is for whatever the one that this thing that we're reading out, whatever one it corresponds to, right? And so one thing that we would be doing here, generally speaking, because we might be loading a data file that has asset types we don't know about yet if we're loading some data file from the future. I don't think that's particularly relevant necessarily, but what we want to do is say if it's less than the asset count that we know about, right? That's going to be a pretty important thing, right? We should probably merge these into the file format, right? Probably. Wouldn't you say? That seems like a pretty reasonable thing to do. I don't know, though. We could do that later, I suppose. But anyway, we got that asset count. We're just going to say we want to make sure whatever the type is, it's less than the actual asset count that we understand, so that we're not trying to access some array that we don't know about, right? And so then for now, I'm going to put to do, support merging. Eventually, we want to support merging and stuff like that. For right now, we're only writing out one file, so we don't really have to worry about that for our testing. So what we're going to do here is just go ahead and, oops, what was that? I didn't mean to create that file. What we're going to do here is just grab, overwrite whatever the asset type stuff was originally, the first asset index and one pass asset index. We're just going to go ahead and overwrite whatever was in there. And we're just going to assume that there wasn't anything, right? And we could assert that was true, right? We could say assert first asset index equals 0. And one pass last asset index equals 0, so that there's like nothing in that array or whatever. So that would allow us to load everything, right? And presumably we'll step through that and see if it worked. But what's going to happen then is All of our slots are still initialized to not actually have anything in them. So once we actually go to load something, right, when we actually do a load wav here, I'm going to take these guys out, right, and recompile. Oh, right, but I commented them out, so that's not going to do anything. So once we come in here, right, you can see that we're doing this debug load bitmap work, right? What we want to do now is be able to produce the same results as debug load bitmap, but without actually ever using the bitmap file, just using our asset file, right? This is where we used to load the bitmap file straight away and do all the work on it. We don't want to do that anymore. So we have work bitmap, and that is a loaded bitmap, right? That's a loaded bitmap struct, right? So that's the bitmap, and what we want to do is we now want to go ahead and reproduce whatever that actually had on it to do all the loading, right? So how do we do the loading in this case? Well, we don't actually have to load the data because we're sort of cheating, right? We already know that we've got all of the data loaded because we, sort of did that for testing purposes. We just loaded the whole asset file in, which is not something we want to do eventually, but that's what we did for testing purposes. So all we really have to do is go find out what's in loaded bitmap and how do we reconstruct that from the data that's in our asset pack file, right? So here's the stuff that we actually need, right? So we got to fill out all of these, right? We got to fill out every last one of these in order for our stuff to work properly because the code is relying on all of these being valid. So how do we figure out all of these things from what we actually have in the bitmap file, right? So let's go ahead and do that. If I come over to Handmade Asset, we know that we've in theory got the bitmap info itself here, right? So what I should be able to do is just use that HHA bitmap structure to figure out all the things that I need. And assuming that we actually saved everything that we need, that should be pretty easy. So here's the HHA bitmap. If I want to figure out the align percentage, that's pretty easy because it's right there, right? It's literally just stored in the file for us because we knew that we were going to need that. So we've got it, right? So there it is. So that's pretty trivial. How about the width? Well, the width is right there. It's the dimension, the 0th dimension, right? All good of the thing. We've got the height, same thing. And we already said that our convention for the pitch is it's always going to be the same, right? The pitch is always going to be exactly whatever the pixel size is times that first dimension, right? So that's already specified. Then we've got the align percentage. Oops, I put that in the wrong place. Then we've got the width over height. And we know that as well, right? Because we know what the bitmap's width is, it's that. And we know what the bitmap's height is, it's this, right? But those are integers, so I want a floating point divide here. So I'm just going to loft them up to floats to get that nice floating point actual specification for the width over height. And then finally, for the memory, where's the bitmap coming from? Well, the bitmap's in that file, right? And if you remember, we've got this data offset thing here in the asset itself. So what we need to do is we're going to need to pull the asset here, right? So we got to be able to do this where we have the HHA asset or whatever. So we're going to actually need to grab that out as well from this thing, right? So we've got the asset there, and then we've got the HHA asset bitmap, so we've got both of those things. So the HHA asset has in it the data offset, which says where the bitmap data was, which means that if we were to add that data offset to our base pointer, which we know where that is, right? It's the game, it's the work assets, right? It's that thing right there. We stored in it the HHA contents, right? So that's the base pointer for the file that we loaded into memory. So we know that the bitmap is just going to be at the offset that we said it was. So that's all we need to do to really say, okay, there we've quote unquote loaded it. We don't have to load. We don't have to actually do the work of loading it because we loaded the whole thing in before. So really, all we're doing is just pointing into the data that already existed, right? And that's pretty much it. That's really all we need to do. So once we've got that, then all we have to do is fix the all we have to do is fix the sound loading to do exactly the same thing, right? So let's go ahead and do that. Here's how the sound was loaded. And I don't remember what this loads. I have no idea. Looks like loaded sound, right? So what we need to do is we need to patch all these things up in exactly the same way that we patched up the other stuff, right? So now what we want to do is say, okay, we've got the sound, like so, and we need to set all of this stuff up, right? So we start by saying we've got the sound sample count. That's going to be equal to that. I believe we just stored that directly. Yep. Yeah, like so. So that's info sample count. We've got the channel count, which is also the exact same thing, right? And then we want to probably assert that the channel count that we have here is going to be less than the array that we have to put stuff in. And then we're just going to go ahead and copy out that data. Not copy out the data, sorry, just point to that data. So we've got the channels, right? For each channel that this thing has, we will set the pointer to the sound samples equal to whatever the data offset is in the file. And how do we figure out what that is, right? Well, we start by saying that we know the data offset for the samples, right? Sample data offset is going to be whatever the asset thing said it was, right? So we've got to do the same thing that we did up there, which is we still have to remember what the HHA asset was, because that's what's got it in there. And maybe that was dumb. Maybe we should have lowered that data offset down one. I don't know. But yeah, it's not really going to matter in any way. The point being, we've got this, and we've got that, right? Just like we had before. So now we know that we start wherever it said the data offset was, right? And this is going to be equal to that same thing we did before. We're going to take the pointer to the base of the file. I guess, you know what? Why did I cast that before? Because we had already set it up to be the correct thing. Okay, I didn't cast it. Good. So we're all good. Never mind. I take it back. Right. So what we're going to do here is we're just going to start at the base of the file. We're going to go however far we think the samples are, right? Starting at the correct sample as indicated by the file for this sound asset. And then what we're going to do is we're going to move forward by however much there should have been in this sound channel, right? So we know what the sample count is, right? We know that the sound sample count is specified. And we also know how big each sound sample is. It's that big. So that's how far we would go. And with that, we'll just work to get the channels cascaded one after the other. Right. So all we really need to do now is just say, all right, that work sound, the thing that we're trying to fill out, right, loaded sound, all we need to do is now actually sort of write into that instead of using the debug load like we used to. And that should really be just about it. I don't think there's anything else that we would need to do. Got to change that to an int16 there. And so that's everything. Now, we probably made some mistakes when we did that, so we're going to have some debugging to do. But basically what we've done now is write all the stuff that we need to do for testing out that asset file, right, and running off of it instead of the bitmaps and so on, right? Or it might just work the first time. That also happens sometimes in game development, and you never know. So yay, our game is back, and that's good to know. Everything appears to be there. Sounds are playing. The sound is streaming properly. The music's still playing. So everything appears to have worked just fine. Who knows why? It's just the way it goes sometimes. All right. Well, you win some, you lose some, and we won some today, so that's always good. Makes up for those times when everything goes wrong, I suppose. So, what do we need to do now? Well, what we need to do now is remember the fact that we're loading the entire asset file at startup, which is not at all what we would like to do, right? What we would rather do, because we'd like to stream our assets, and we already wrote all the code for streaming assets, like we've already got it threaded and everything, all this stuff is set up for it. So what we would like to do is only load the parts of the asset file that we need at any given time instead of loading the whole thing, right? And that's going to involve some work with our platform layer, because at the moment, the only thing we put in the platform layer was just the ability to load entire files at once, right? And we'd like to stop doing that. Okay. So, first things first, let's just briefly run over this code slightly and see if we want to just flat load some of it, right? I was talking about the flat loading before. And so what I was thinking is, I guess we might as well not overcomplicate things. Since we have an asset tag here, right? What I'm thinking is maybe we just make it so that the asset tag is just used directly the same as it is on disk. Because I don't anticipate there being a lot more stuff happening with asset tags in terms of annotation that happens at load time. So I'm thinking that maybe we delete asset tag and we just use HHA tag in here, right? So we go ahead and do that, and then everyone who was using asset tag uses HHA tag instead, right? If that makes sense. Now we could actually, I suppose, do that in two different ways. One is we could leave the name asset tag if we'd rather have that be a thing, or we can switch it to HHA tag. I don't have a personal opinion on that. I think I'm going to use this notation so that we can see which things are in files and which things aren't. I think that might be what I'm going to try here. And if we don't like that, we can always change it. But that's my gut inclination at this moment in time, right? So that's what we're going to go with. So there we go. That I just changed the name there, so now we're just using the asset tag struct from the file, and there it is. So that's all good. And now what I'd like to do is, now that we're just pointing to an array of asset tags, what we can do is once we load it, when we do this thing here, what we can do is instead of allocating space for it, we can literally just use the stuff we loaded out of the file, right? So this would be that, and we'd never have to loop over this at all, okay? And so I'm going to go ahead and delete that, and I delete the to-do that says decide what to do about flat loading, because that's exactly what we're doing right now. So now I run, and as you can see, we no longer process the tag array at all, right? We no longer loop over the tag array, but everything still works, because the data on disk is exactly the data that we want. So we can just point straight into it after we load it and be done. Question 2, can we do that with our HHA assets? Well, if we take a look at the way we've done it, we've split up our assets into the asset and the asset slot, and so there's really no reason why we couldn't do that. We could just decide to go ahead and vaporize asset, and then it becomes HHA asset, like so, right? So let's go ahead and try that as well. Can't think of a lot of reason not to do it, so let's go ahead and do it that way. That would look like this. These are now no longer have to sort of access that thing, right? Again, do the same thing. HHA asset now, and just get rid of those. And we no longer need to allocate this. This will just point directly into the asset array like so. And again, that would get rid of this entire loop, and that's all very nice. And now let's see how we're doing. All good, right? And so basically what we've done there, again, is just removed two completely unnecessary things from our code, which was the translation of the file data when we really didn't need to do it, right? So now what we do is we're just issuing one load to load in all that stuff, and we just point directly into the buffer after we've loaded it in, right? So that seems all fancy and good. All right. So now that we've done that, there's a question of what about this one? And the answer with that is, remember, that one is not something we can flat load because it's actually going to be variable, right? It's going to be something that we have to sort of process because it's stored in a different way. It's set up to allow us to say which things it's adding to, so it doesn't just flat load in there. And it's worth noting that these won't quite do exactly this flat load in the future. Potentially, we may allocate a bigger array of assets than we actually have because we might have multiple files to load, right? So we'll maybe take a look at that in the future a little bit as well, right? So there we go. Now we're flat loading those. So let's go ahead and push forward on not just loading the entire file at once, right? Because right now what we do is we load that entire file at once, and that's not really what we want to do. What we want to do is something, you know, a little more piecemeal. We want to be able to say, look, this is a giant asset file. It has everything in it. I just want you to load a piece of it at any given time, and I'm going to process just that piece, right? So now we need a more, this is the part where we define our more realistic file API, the one that we're actually going to be shipping on. So we need to start actually thinking about it. And if you remember correctly, I kind of put this off when we were doing things, when we were building the platform layer, for precisely the reason that, again, always write the usage code first. And I knew we were just nowhere near being ready to write the usage code, so I didn't want to do anything like that. But now we've arrived at a place where we can write the thing that actually uses the file API that we want for our asset loading. And so now is the time to start to think about exactly what this API should look like. So what am I going to do, right? What am I going to do now? Anyone out there who didn't say write the usage code first had better be a first-time Handmade Hero viewer, because you always write the usage code first. That is how you start at a good place with any API design. You always, always, always write the usage code first. And I can pretty much tell you from experience that almost everyone who designs APIs inside their own code or elsewhere never follows this advice, and that is why all APIs are awful. So, write the usage code first. What do we want to do here? Well, let's imagine we're actually doing the thing that we want in the final shipping game, right? So we have multiple asset files. Why do we have multiple asset files? We're trying to fit under the FAT32 limit. So we had to break our giant 16 gigabyte asset set into multiple chunks, thing one. Two, maybe we had to patch something, so we've got a big asset file and a little tiny asset file that patches some of the assets in it or something. Three, we shipped a DLC that may or may not be there, right? So the person may or may not have ever downloaded the update to the game, and that would just be an additional file that would come in. Stuff like this, right? So we might have multiple asset files, and what we want to do is load and merge them, right? So what's that going to look like? Well, we're going to have something, right, like a list of files to load from the operating system, right? And in fact, I guess we could even do that. We could even sort of spec out what that API should look like as well. We could do something like, you know, let's say platform directory or platform file entry or something like this. File entries, you know, or platform file group, let's say. I'm just going to say we get back a file group. We say platform, you know, I would like you to get all files of type, right? And I pass HHA or something like this. So it's like, I want you to give me all the HHA files that there are, right? Just give them to me. And again, we're not going to be more explicit than that because this game doesn't go searching through directories or anything like that. There's the directory where the game data lives. We're assuming that the platform layer understands where that is because it's where the executable was, or it knows because on that particular platform everything goes in one particular place or whatever. Like on a console, it's the DVD or what, who knows. But basically what I want you to do is I want you to gather all of these files of type, and maybe they're even in different places. Maybe like you're on a console, and it knows it gets some from the hard drive and some from the DVD or whatever, all that stuff. We don't want to care about that in the game because that's platform specific, right? What we do want to say is get us all of those data files, right? And we could even have specifiers for what these are, but for right now we'll just use that string. We'll say we'll pass what the extension would be, let's say, right? So then what we want to do is we want to go through all of the files in the group, right? We want to say for each one of the files in the group. So we want to do like platform file, or probably just something like index, right, equals 0. Index is less than file group. File count, something like this. Plus index. And then what we would do is when we get here, we're just going to say that we can open any one of these files that we want. So actually, we've got another thing that we would want to do here. And again, you can see what I'm doing, right? I'm thinking through how I want to use this API, and I'm writing the code that would be the best case for me as the user of the API first. And that's always where you start. So I'm going to go here and say that we have an asset file, right? And an asset file is going to have some kind of handle that associates, that kind of tells me, right, if you will, which asset file I'm talking about, right, or something like this, Okay. And that actually reminds me, that is going to be kind of interesting. I'm interested to know, now that I think about it, how we're actually going to do some of the loading thing. I'm thinking about an interesting problem that we're going to have in the future. I'm not sure exactly how we would solve it. It's going to be interesting to see when we get there. Anyway, so I have an asset file, and there's going to be something like a platform file handle, right? There's going to be something there that I would use to reference this file, right? That I would say, I want to load something out of this file, or whatever, right? And then in here, I would have, at the very top, I would say I've got something like an asset file count, right? Or a file count. And then I've got an asset file, files, right? And however many files I opened, there's going to be an entry in this asset file, and it's going to have an open handle to every single one of them, right? So I guess really the first thing I would do is once we get all the files of that type, right, I would then fill out this part of the assets structure, right? I would say this is how many files we have. This is the files themselves, right? And it's going to be push array arena. File count, right, and asset file, right? So we go ahead and push those on. We then go through every single one of them, right, one at a time, and we're going to open them, right? We're just going to open them up. And as part of opening them up, you know, I don't know, maybe we also in here, just because, maybe we store the header, right, which gives us all of that information that we actually need. Right, all of those offsets and stuff that we actually, you know, might want for loading things out. Now, it's kind of a little bit extraneous. It's not clear that we actually really need that to be persisted, so I could do it locally. But, you know, it's really no big deal, so I think I'll probably just store it for now, and that way we always can kind of refer back to it if we want to or stuff like that. So, I push the array on there, I go through here, and I'm going to say for every asset file, right, I'm going to take a look. Right, here we go. There's our file index. This could be file index. So I go in here and I take this file, and what I want to do now is I want to open the file, or try to open the file, right? I want to see if I can, if that makes sense. So that would just be some kind of call to the platform layer, which would be like, you know, platform open file, right? And what we would do is we would pass it, I guess, just the file group and the file index for now. I don't know. Maybe we would want something a little bit different than that. Maybe we would want something more like file group, you know, file group names or something, or files, and then we'd just do it like this. You know, I'm not sure. Something like that, maybe. I don't really know. But we're going to leave it this way for now. I think that's the way we'll do it. Excuse me. So when we open a file, we may get the file handle, we may not. So we're going to want a way of saying, you know, platform is valid, or platform file handle is valid, right? We're going to want to be able to say, did it actually open, right? Did it work? And there's another way we could do that too, right? We could actually go in and do something slightly different, but I don't know. So, well, and you know what? Let me talk about that for a second. We'd do something like this, right? We'd say platform is valid, and if so, we'd read the header, right? We'd go ahead and read the header. We'd say platform read data, or read file data, or read data from file, right? And we would pass the file handle. I'm sorry. No, that's right. We would pass the file handle, we'd pass the offset, we'd pass the size of the thing that we wanted to actually read, which is the header, right, in this case. And we'd pass the location that we wanted to read it to, right, where we wanted to put the data. So if we were to actually do it this way, now we've got another thing. We've got to do this as well, right? We need to see whether this succeeded, because maybe, you know, in between opening the file and reading the file, it didn't get it, or maybe the file's like been truncated and that the header is like not there, all there or something, right? And we'd have more, so there's more errors here and that sort of stuff, right? So what I think I'd rather do is just not do that and say that we just do this, right? Files, you can just do all the operations that you want on the file. And then at the end, all you have to do is say platform no errors or something, no file errors, and pass it a handle. And if there's ever been an error on that that's like hasn't been cleared out, then, you know, it's considered an error. This is basically like, you know, do we have an invalid code path yet? I don't know if we do. Come on. Looks like we do. So yeah, so, you know, if there were errors at all, then it wouldn't do any more processing, and it doesn't matter whether the error was here or here, because, let's be honest, we don't care. We don't care where the error was. All we know is we didn't get back a header. And we don't really need to know when that error occurred, because we can't do anything different about it anyway, right? There's not like there's some magical thing that we're going to be able to do. If we can't open the file, we can't open the file, right? So in here, we probably want to assert, and then we also probably eventually have some way of notifying users of bogus files, right? We might want to be able to put up, you know, when we have a little bit more of a UI or something that comes up, message boxes or something, we might want to notify the user like, hey, there was an HHA file in here, but it's busted, which is probably not what you wanted. Maybe you should check your download or tell Steam to like reinstall the game or do whatever, you know, do something to try and restore this game to working order, because it's probably not working the way you think it is, right? So there's that. Okay. So that's the way I would like that to work. If we actually got the stuff okay, then what I'd say is what we want to do here is we want to sum up the total counts of things, right? Because we have tags and we have assets. So what we want to do is we want to actually sort of sum how many of each of them there are going to be, right? And the same is probably going to be true for the asset type array as well. Like that's a thing that kind of has to get merged. So we'll have to see exactly how we want to do that in order to do like our layout. This will be kind of interesting to do. We'll probably write a very inefficient one first, which honestly we'll probably end up shipping because there's only going to be like 3 or 4 of these files at maximum anytime anyway, probably. So the efficiency is not going to matter, but it would be an interesting file. It would be an interesting problem to think about for extra credit, if there was such thing as credit on Handmade Hero, of how you might set up these things to be merged in a expedient fashion. Let's say it's just something to think about. All right. Okay. Here we go. So when we actually determine that there are no errors, what we would like to do is we would like to sum up some of these things, right? So we would like to go ahead and sum up some stuff. So we've got, you know, the tag count, and what I'd like to do is start the tag count at 0 and sum up how many we have total in all the files, right? And the same is true of our asset count, right? I'd like to start at 0 and sum it up. Okay? So inside here, once we know we have a header, what we could do is also in there try to validate the versions, right? Like in here. Which we may want to do as a separate thing just so we could report the error a little more cleanly, right? So do something like this. Probably check both of these separately even, right? So assuming that it's a version that we understand and, you know, and it's a, an actual file that we think we understand, and here we would have, again, notification stuff to some degree. I'm not sure how we want to do that eventually, but maybe, yeah, we'll think about that pretty far down the line. Assuming all that stuff worked out okay, then we would just say that, you know, we're going to sum up how many there are, right? And I probably also want to mark the file. You know, one thing that I would want to do is say that the file handle itself had an error in these cases. Mark platform, mark error, or something like this. Platform file error. And I would say, you know what? This thing, it's messed up. Okay, this one we already, this one is actually the case where we're checking that. Oh, you know what I could do? That's pretty interesting, actually. I'm actually thinking that maybe we could do that slightly differently as well. Because we could instead do this, right? We could do it this way, and then we don't ever have to deal with more than one of those, right? And these would eventually, be some kind of an error message that we would put here, right? It would be like magic, HHA file has an invalid magic value, or something like that, or HHA file is of a later version, or some, who knows? We'd put some, we'd make this probably go through some kind of system that would report errors eventually, but, something like that, just to give you the idea. That way, the errors all go through the same system, so we only check the error once eventually at the end, and then we'd assert here, if it was wrong. The asserts obviously won't compile into the game in the final release version, so the user would never get an assert, but we would get one, so for our debugging purposes, it would stop us immediately, and we'd be able to see what the problem was at that point, because obviously we shouldn't ever have this problem. This is problems that happen only when there's a corrupt files or bugs in our file reading code. So that's what that would look like, right? And that all seems pretty good, right? That all seems pretty good. So let's see. Just a couple other things we may want to do there, but let's see. So if I do that, I do all that reading, right? I think now I've got enough information to actually allocate the arrays properly, right? I've got asset slots and tags, right? And these are all going to be push array stuff. Oops. These are all going to be push array to create what we need in terms of storage. So we've counted up how much we need to store the data from all the files, and then we are going to allocate basically blocks where we can put all the data, right? So if we wanted to do that, after we finish, we need to actually load the data into those locations. So then we would have another loop through our files, right? And I guess I should probably change this to be that. So then we would have another loop through our files where we would actually work with them. And you know what we might want to do here too? We might want to do something along the lines of begin all files of type, right? Or get all files of type begin, and then platform get all files of type end, right? Because the OS may require resources to do this, so it's kind of like, a thing where once we've opened the files, we don't need it to waste any more resources on that list of files. So I just want to give the operating system layer the opportunity to deal with that gracefully, right? So in here, we do push arrays to get the slots that we need, and then we just go through and actually load all of the data out, right? We load all the data that we actually want to load into the locations where we want to load them, right? So we'd have like asset index or asset count here, right? And tag count here. And then at the end, after we loaded them all, we would want to do an assert that the asset count equals the asset count. Make sure we loaded as many as we said we were going to load, right? And so this gets back to sort of the sort of strange thing I was talking about before. Excuse me. I'm going to do this in a very inefficient way. What I'm going to do is I'm going to say, since we care about organizing things by asset type, I'm going to say that we have an asset type ID, right? That we loop through all of the asset type IDs that we actually have first, right? So we go through all of the asset type things we have, like so. So I go through every asset type ID, and for every asset type ID, I go through all the files, right? and I look to see which files have assets of that type, right? And I can do this in a super janky way, which is what I'll do first. This whole thing is pretty janky. And this is what I said, like, it'll probably still execute extraordinarily fast anyway, because there just won't be very many files. And so I don't know that we'll ever fix it, but point being, you know, it's something to think about. It'd be interesting to think about how to write this in a way that wasn't brain dead, right? In fact, I might do to do exercise for the reader. How would you do this in a way that's scaled gracefully to hundreds of asset files? Right? Or more, or however many. So, what I'm going to do here is say, all right, so for every asset type ID, I want to go pull out all of the assets in the file that are of that asset type ID and put them so that they're continuous in my array. So I'm like merging, right, all of them together, if that makes sense. Yeah? So hopefully that's, you know, relatively clear. So if I want to do that, what would I do here? The first thing I would do, I probably would need HHA asset type, right? Asset type array. I would probably want to actually load the asset type array for each asset file. And really, we don't need to keep this around, so I should probably be putting these in a transient, a fully transient arena, but that's something we haven't really gotten to yet. So I should do something like here to do, if we ever do thread stacks, then there are asset, well, actually, no, I'll put it in here. Right, if we ever do thread stacks, asset type array doesn't actually need to be kept here. Right? If that makes sense. Okay. So, when we come through here and do this little dance, right? What I'm going to do is say, I've got this asset type array. I'm going to assume that in here we would load that array, right? So I'm going to assume in here that we would go ahead and load it in. Do something like platform read data from file, from this file handle. It would be at the file header location, right? So file header asset types, right? And the size of it is going to be however many there were times the size of an asset, an HHA assets type, right? So it would be like file header asset type count, right? So something like that. And that would read into the asset type array. And the asset type array, I guess I should just make this a size, right? Asset type array size. It's going to be this guy. That's how big it is. And in it goes, right? So what I need to do is I need to allocate space for the asset types. And of course, I can't do that till I've actually read the header in, right? I can't do that till I've read the header in. And again, if I want to, I can sort of do this in all in an entirely incremental way, right? I can say that the file header, I can just make sure that the file header itself is zeroed at the beginning. I assume we have a zero struct, do we? I don't actually remember if we ever implemented that. Zero struct, yeah. So we can just make sure that the header is zeroed at the beginning. We can then do the read. We don't have to check to see whether the read succeeded or failed because we don't care. We can then go ahead and set the asset type array, right, to be whatever that size is, right? So we can just do push array, like so, and off we go. So we would do asset type array size, or sorry, push size, rather. HHA asset type. We do a push of that size from whatever our arena is, which, to be honest, I don't remember what it actually is, just called arena. There we go. So that would give us space. We'd then read it in, and that would be that, right? So off we go. yeah, I guess I can't really do much compiling here. We're getting close to the end of the stream, so I should probably go ahead and nerf some of these guys out so we don't leave ourselves in a non-compiling state, but we're getting close here. So I'd read those in, and then in here, when I loop over them, right, I would go ahead and say, okay, for each file, I'm just going to go through its asset array and see if it has any of this type, right? So I'm going to do something like, you know, if the source type ID equals the asset type ID, right? And we could call this like dest type ID, right? Dest type ID. Then I'm going to do the block load of its assets into this location, right? Really pretty straightforward, if that makes sense. Very, very simple. And there's one other thing that we probably would want to do, actually, now I'm thinking about it, as we do this indexing, which is we would want to do a tag base. So remember, the tag arrays are by index. So all of the assets in one file are assuming that their tag array starts at 0. But it won't start at 0 when we actually concatenate them together. So we'll have to rebase the assets tags as we go through in order to make them all line up in the tag array. That's kind of annoying when you think about it, because it does mean that we will have to touch the asset structs on load, which I would have preferred not to do, right? If that makes sense. I would have preferred to be able to just flat load it and be done. But it looks like there would be one thing we'd have to touch, which is to slide the offset for the tags over, basically. Now there is, so that could mean that there is a better way that we should do our asset stuff. Although, no, it's still, then it would be variable size. So I think that's probably still going to be the easiest one for us to do. But time is of the essence here. So I'm going to go ahead and if zero this out for now, so that we don't leave ourselves in a non-compiling state. And what I'll do here is just kind of nerf the things that we added, and so that we don't have that problem. Okay, so there we go. I'm just going to leave us in a compiling state here. There we go. Everything's still working nicely. So I'll just keep writing this for the next 3 minutes or whatever till the stream runs out. And then tomorrow we'll pick back up on how we want to do that sort of rest of the merging and that sort of stuff. All right. So as we go through the files, again, we look up this file. Now I'm just going to go ahead and in that file we've got the asset type array. So I'm going to go ahead and say that we've got you know, that source, and the source is going to be the file asset type array. Should probably also say that we're only going to process files that don't have any errors. So if platform file no, what was it? Platform no file errors. If this handle has no errors, then we will use it. Otherwise, we will not, right? And it's arguable that we maybe shouldn't even have included it in the asset file list if it had an error. Maybe that's the smarter thing to do, but I'm just gonna for now leave it this way. So when we get in here, we're gonna go ahead and loop through every asset type index, right? So this is basically the index from the source, right? The thing we're reading out of. That's gonna go from 0 to however many there were. So this is in the header. This is asset type count, right? We're going through them. And for each one of those, we have our source. And basically, if that source is the right type, then we're going to do the block load, right? So we're going to load that set of assets in. So that'll be another platform read, right? That'll be platform read data from file, like so. So we do platform read data from file. And we would take however many of them we're going to read, and we would want to kind of slide, if you will, the we'd want to make our range for the dest. We would want where is our dest? We haven't done our dest yet, right? We've got this asset type, right? Our dest. We want the dest here. Maybe we should do dest type and source type, like that. This dest type is going to be the array that we're actually trying to fill in, right? Assets, asset types, plus dest type ID, right? And that's our dest type. So our desc type, for as we started off, is going to be, because remember, it's got the first asset index and it's one past last asset index, right? So what we're going to do is we're going to have our asset count. We want to start it off assuming that it's like at the asset count. And then as we go, we're just going to kind of widen it out to fit, wherever in fact, you know what it is? It's really just this, right? It's just going to say one past last index is whatever the asset count is now. So the asset count will like increment as we load each individual asset, right? So yeah. All right, so we've got a bunch of work to do there, but we'll do it tomorrow. For now, let's go to the Q&A and go ahead and, well, let's go ahead and just, ask some questions. So if you have questions about what we did on tonight's stream, please go ahead and ask it now. Put Q: in front of it so I can see it and answer it. Of course, I don't see any questions. Everyone understood every last thing I did tonight perfectly, which is good news. Everyone just knows how to do it. Sorry if this has been answered. What's your general rule for making a variable a pointer versus not? So usually there's two reasons for making something a pointer. The first reason is if you are afraid that the cost of copying it around is going to be too expensive. So to give you an example, right? Let's go ahead and take a very simple case. If I were to make a function here, void foo, and I had another function, void bar. Let's suppose that I had something here that was like a struct that they were both going to talk about, my struct, right? So I wanted to find some data that both foo and bar are going to operate on. If it's very small, like this, then if foo has a my struct, right? And it sets part of it to be equal to something. And now it would like bar to use that thing. Yeah? The question becomes, should this be a pointer or should it not be, right? That's sort of like the thing that you're asking, right? Because in here, it uses this or something like that, right? I don't know what it does with this value, but maybe it does, some math, right? So let's start thinking about this particular problem. And I'll go ahead and compile this even, and we can step in and see what happens, right? So let's first take this incredibly simple case. Let's step in and see what happens. So here we go. Okay? Oh, well, you know what? I got to actually call it. We won't be able to step into it if I don't ever call it. There we go. So let's step into it. Here we are. So what's going on in the compiler at this particular time? Right? What's happening here? Well, if we look at the disassembly, we can see exactly what's going on, right? Here is the number 5, right? That's this. And here is a pointer to this structure, right? It's saying the location of the structure on the stack, right here. It's going to copy the 5 into there, right? It's using this as like a target, saying put the 5 in there, right? So there it goes. It's moved in there. Then what's going to happen is it's going to move into ECX, which is a register, what is at the location of struct, right? Which happens to be that 5. It's going to move it in there. And then it's going to call bar. Okay? So in we call bar. It's going to grab, excuse me, what's in ECX, store it to the stack, because it's trying to save the variables here. It's doing its little standard dance, because normally we're running without optimizations, right? So there's no optimizations here. It's then going to load dwood pointer struct, which is this right here, right? It's basically, it's taking the value that it got passed, it's storing it to the stack, and it's immediately reading it right back from the stack, right? Again, the optimizer would not be doing a lot of this stuff, but we're in unoptimized code, right? Then it does the add of 5, which is this 5 right here, to our existing 5 to get 10, right? At least it should be 10. And then it's storing it back out, that value back out to the stack. It's interesting, you can see, right, the debugger is viewing what is on the stack. So until it actually moves it back out to the stack, it doesn't show it in the register. Once it moves it out to the stack, you can see it. So the debugger is always inspecting the stack, basically, is what that's telling you, right? So what did that do? Well, what it did was it actually copied this by value, right? It actually copied the whole thing, okay? And so that's what's actually going to happen if I don't pass this by pointer. So one thing that might cross your mind is how expensive is it to do that? What if this were very large, right? What if this were 32 things long, right? And we only use, you know, and maybe we use all of them even, right? So we're going to use all of them or whatever, and we're going to initialize all of them. So pretend we were doing a loop where we initialize them. We don't really have to do that, but pretend we did that, right? So we actually want all of them. So now what happens when we do this, right? So here's the disassembly. And, right, we go through here. It's loading in. It's actually trying to figure out where to store this thing. Right, it has to do that offset of 6. So it's figuring out where that's going to be. It's going to go ahead and actually put the value in there. And then you can see it gets to this thing right here, this rep mov s, right? And what it's going to do is, you see that 80h there, right? That ECX, that 80h. That's actually, if you look at how many we've got 32, and they're 4 bytes each, right? So they're 128 bytes. So we can see as it loaded in, 80h is OX80, right? It's 128. What it did is it said, I got to copy 128 bytes right now, right? Because I got to copy all that stuff onto the stack for calling this guy because he wants the whole thing. So that's going to full-on byte a copy of 128 bytes right now, right? That was it doing it. And that doesn't get any better, right? Like, I mean, that could be huge, right? That could be 4096 or something like this, right? Or I guess let's do 1024, which times 4 will be 4096, a whole page of memory, right? Here we go. We come in here, take a look at the disassembly. What's it doing, right? Well, what it's doing is this. Copying 4096 bytes every time you want to call this function, right? There it is. So yeah, doing a lot of work. So why might I want to pass a pointer? Time number 1, the thing is large. So what I'd rather do is this, right? What happens if I do that, right? Well, if I do that, oops. Well, if I do that, now when we look at the disassembly, it's not going to bother copying it. It's just going to send the pointer, right? So in here, when we do this, right, you can see that rep mov is gone. That thing that does the block copy is gone, right? So all it does is it takes the address of the thing, which is this, right? And it's going to move the address into the register that it's going to pass, right? That's all it's going to do. So it does that. We call bar. Bar grabs that pointer out now. And now, from now on, it's just going to use the pointer to access the struct, right? And be done. So it's much more efficient now to do that. So that's the first reason you might pass a pointer, because the thing is large. But there's a second reason you might pass the pointer, right? There's another reason you might need to pass the pointer, okay? So let's take a look at a different scenario. I'm going to unwind this a little bit back to where we were before. Before we had a big thing, so before there was any reason to pass the pointer. And remember, you know, it can actually be, well, never mind. I'm not going to bother saying that. So anyway, off we go. What's another reason to pass a pointer? Well, let's suppose that this code actually is going to modify x, right? Well, what happens if I just do this? If I just do this, then what's going to happen? I mean, think about what happens in this code, right? I'm going to set x equal to 5. I'm then going to pass it. And in fact, you know what, I should probably point out, you know, right here, I want to find out what it thought, what, you know, what x actually ends up being, right? Well, if this is going to modify x, when I come in here and I set x equal to 5, and then I call struct to have it go ahead and, you know, increment x by 5, when I come back, what I will find, of course, is that my struct still has 5 in it. And the reason is because if I pass something by value, it's passing an entire copy, and this guy is working on the copy. But a lot of times that's not what I wanted. I wanted that function to work on the struct, and I want to get back the results of that, right? So one way to do that is obviously to have a return value of my struct, right? So I can do this so everybody's doing by value. This is the functional style, you might call it, right? I pass in a struct, I get a new struct back, and I just overwrite my old struct's contents with the new one, right? But again, that could be very inefficient if the struct is large. All these copies, the optimizer may not know how to do that efficiently. So another thing I could do is just say, you know what? No, we're all operating on the same memory. So I'm just going to pass you a pointer to struct. And then when you modify it, I will see the changes because it's the one that I'm using too. We're both pointing at the same place, right? So here we go. We set it to 5. We call bar. And now when we come out here, our struct is set to 10 properly because we were both looking at the same struct, right? So hopefully that answers the question. Usually it's very unambiguous whether you use a pointer or not. If the thing is large or you're both trying to operate on the same one, you're going to use a pointer. If it is small and you don't care, you're going to pass by value because usually it's just more efficient since you don't have to pass a pointer that then gets... You don't have to pass the thing which tells you where the thing is. You can just pass the thing. And that's always going to be a little more efficient than doing that in direction, right? SSS McGrath says, I don't completely understand your aversion to using the C standard library. Is this just an HMH thing for teaching, or do you just never use the standard library? I just never use the standard library. Pretty much. That started with Granny. Granny was the first thing I shipped that did not require the standard library and could be compiled completely without it. The current code base that I'm doing at work doesn't use the standard library at all either. So the next game, the game that we ship, hopefully next year, will not use it either. So the reason for that is twofold. One is I don't trust it. And the reason that I don't trust it is I've had lots of bad experiences with it. For example, you will call some math function in the standard library and it's doing a ton of extra work it doesn't need to do, right? So I don't like the idea of maybe calling sine or maybe calling atan and having it do a bunch of ridiculous stuff that's not what I wanted, right? I want to know exactly what the code is that I'm calling on every platform, and I want it to be the same, right? So I want to implement it myself. I want to implement atan2 exactly the way I want it, and then I want to know it's always atan2. I don't want what some GNU library maintainer thought atan2 should be doing. I don't want what the C Standards Committee thought atan2 had to do. I want what I think atan2 should do, and I want it to do the same thing everywhere, and I want it to be only what's necessary, right? So that's one thing. The second thing is I just don't like the API. Like I said, I don't like their file API. I think it's written incorrectly. I don't like a lot of the ways they've structured things. It's incomplete. There's a lot of things that the file API doesn't do properly. Globbing, for example. Like, it can't iterate over the files in a directory that have a particular name or something like that, right? So it's just, it's not even a good standard library. It doesn't have the features I actually want. So I know I'm going to implement half of it anyway myself because it doesn't have the things that I need. And so at some point I just looked at it and I was like, oh, and then one other thing is unreliability of linking. The more stuff you rely on in the standard library, the more Microsoft screws you by shipping really unreliable side-by-side assembly, DLL, lineup nightmares. I mean, I can't tell you how many times people have sent me executables of like a game they were working on, and I go to run it, and it doesn't run because the proper MSVC redistributables weren't installed, right? If you don't link with the C runtime library, you never have that problem. Now, of course, I've told you other ways you can get around that is just link with it statically, which I highly recommend people do if you're going to use the C runtime library, but that's just an example of the kinds of annoyances that happen. Or I want to link with it and I don't have the C runtime library .lib installed on the machine in the right way because when Microsoft's compiler got installed, it didn't do it right, or the path is set wrong or whatever. It's like, forget it. If you never link with that stuff, you just never think about that again. So yeah. And that's something I did recently with the current code base. Is the first time I've ever done it. The current code base uses no link libraries whatsoever. The only one is kernel 32 on Windows, so that I can get proc address. Everything else is done dynamically, so I literally don't even install the platform SDK. The only thing I do is I link with kernel 32, and I copy and I saved kernel32.lib right into the source tree. So there are literally no source paths involved in building our latest code base. And let me tell you, it has been awesome, because I go to a new dev machine and there's no BS, right? There's no fudge. It's just, it builds, right? There is no way it can't build. You don't have to call VCVars all. You don't have to like set a path. You don't have to install the platform SDK. You don't have to install what version of DirectX, blah, blah, blah. It's like none of it. It just builds. And then from now on, I will never think about that, right? Which is great. So. How and where will users' save data be stored? So that will be a separate thing that we'll deal with a little bit later. And that is entirely platform dependent, right? So we will basically define an API when we get to the point where we have actual user data to store. We'll define an API at that time. Remember, always write the usage code first. So when we get to the point where we want to save user data, we'll do that. And the platform will be the place that decides where it's stored, because if it's running on Steam, it's going to want to use like Cloud Save. If it's running on a console, it's going to want to use whatever their thing is. If it's running just in standard Windows, it's going to want to use the Windows app data or whatever, wherever the latest places they say you have to store it. You want to basically just have that be pushed totally to the platform layer, because every platform is different. So the main code all it will know how to do is issue commands of like, here's my user data, please save it or whatever, or update it. All right. We good? I think we're good. I'll really quickly run through the topical questions. What keyboard are you using? This is a DOS Keyboard 3. After I got extraordinarily mad at the DOS Keyboard 4, which many of you saw on stream. How long have I been developing games? I've been programming for 30 years. I've been in the game industry for 20. Let's see. Why brown switches over blue? I don't like the heavy clicking. I grew up, my favorite computer to type on growing up was the Amiga computer, and it had a softer touch keyboard. I still haven't found anything that I like to type on quite as much as that keyboard, but blue switches are a little too hard for that. Brown are closer. Let's see. What did you have on your arms? Those are my wrist braces. They keep me from getting tendinitis, I find, so I always use them. And that. Do I like dogs or cats? I'm fine with either. If it's gonna be my pet, it's a cat. I don't really. Dogs are too needy for me. Raw syllabus. How far do you think you are in terms of stream days from implementing game logic in terms of play versus platform? My ballpark was somewhere around day 200. Would be where it would be, because days are roughly an hour. So if you think about how long that is, like 200 Handmade Hero days is 200 hours. So divide that by 40, that's 5 work weeks. And 5 work weeks to build a complete engine is not very long. But we've been making pretty good progress, and it does seem like probably about there. So, day 200, day 250, something like that. I just got 2 RPI2s. What do you think about the RPI2 in general? I have not seen an RPI2. I only had an RPI1. What do you think about Intel INDE? Sorry, I guess I don't know what that is. Is it something... Integrated native developer experience? Is that what we're talking about? I guess I don't know what this is. A cross-architecture productivity suite that provides developers with tools, support, and IDE integration to create high-performance C++ Java applications for Windows. Well, I mean, I guess I've never tried it, so I don't know, but I'm not sure what it would really do for me. I mean, the only thing I use MSDev for is the debugger, so if it had like a really great debugger or something, maybe. But, you know, otherwise, I'm not sure what I would be doing with it. All right. Looks like we are done with questions, which means we are done with the stream. So, let's close this down. All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It has been a pleasure coding with you, as it always is. And I'm pretty happy with where we're getting here. We're almost done with the asset file stuff. It's looking pretty good. Again, you know, it's pretty cool when you think about it, the very limited amount of time that we spend on things. You know, we'll spend like 20, 30 hours on something and have a crazy list of features. Like, we do streaming sound overlapped with, you know, on separate threading with our sound mixer that does pitch shifting and volume panning and all this other sort of stuff. Like, all going through the asset system, which is all streamed and loads, you know, in the background and all this other sort of stuff. Like, if you think of how short we spend on most of our things, we get you know, a lot of features in there. So I think we should be pretty happy with that, because, you know, a lot of times you'll get a commercial game engine that can't even do some of these things. And we have been pretty consistent at being able to do some pretty powerful stuff so far. So I'm pretty happy with how little time we have spent doing any individual piece of this, and yet we've gotten some pretty industrial strength stuff out of it. So I think that's pretty darn cool, and sort of validates what I tend to think about things, which is that making stuff from scratch really isn't that hard once you kind of get the hang of it. And it's something that you always can build on going forwards and know that it works the way you want it to, you know. So anyway, that said, we will continue with the asset file stuff for a couple more days, getting it running smoothly with the Win32 platform layer, and also making sure that we can load multiple asset files and merge them. And so I hope you'll join me for that. We'll be back here again 5 p.m. Pacific Daylight Time tomorrow. Same time, same place, here on Twitch. In the meantime, if you want to follow along at home with the source code, you can pre-order the game on handmadehero.org. It comes with the source code. It's this handy little pre-order button here. So if you want to play around and experiment with it yourself, you can do that. We also have a forum site where you can ask questions, get an annotated episode guide, use ports to Mac and Linux, that sort of stuff. We also have a Patreon page. If you want to support the video series, you can subscribe there. And we have a tweet bot, which tweets the schedule. So if you ever want to catch the stream live and you're not sure when it's going to be, the tweet bot's the place to go for that, and it will keep you informed. Thanks, everyone, for joining me, and I will hopefully see you here again tomorrow. Until then, have fun coding, and I'll catch you on the internet.